The topic of this video is significant figures and how to count them. The first step in order to be able to use significant figures is to be able to count significant figures. In the two examples below, you can see there are various numbers displayed. In these examples, counting significant figures is very straightforward. In the top example, we have 1, 2, 3, 4, and in the bottom, we have 1, 2, 3, 4, 5, and 6. Where some people get lost is when zeros are introduced into numbers. So in these examples that I've just shown up on the screen, we can see that there are zeros interspersed in different positions throughout these numbers and examples. Fortunately for us, there are a series of rules to help us figure out what are and aren't significant figures when zeros are introduced. The numbers that I've loaded here have various zeros highlighted in green or red. The zeros in green are examples of zeros that are counted as significant figures, whereas the examples in red are zeros that are not counted as significant figures. And we can further clarify this by introducing some of our rules. So our first rule is that zeros at the beginning of a value are not significant. They simply set the decimal place. Examples for this are shown here. Our second rule is that zeros after a decimal and after a non-zero digit are always significant. These examples are shown here. So you can see that these zeros after this decimal count as significant, as well as here. These zeros after another significant figure count as significant, and here. Our third rule is slightly more gray. Zeros at the end of a value that contain no decimal point may or may not be significant. Our two examples are down here. So this zero may or may not be significant, and these three zeros may or may not be significant. Unless these numbers are transformed to scientific notation, where a designation of significance is clear, you can treat these zeros as not significant, such as this example here. However, if we introduce a decimal point at the end of a number, such as here, now we have denoted that these three zeros are indeed significant. So this has gone from 2 significant figures to 5, whereas this example with no decimal point still remains at a significant figure number of 4. Our last rule is that zeros between significant digits are always significant. My motto is that if a zero has been placed in between numbers, you may treat it as any other number that could be there. So in these examples, highlighted by these arrows with 4, this zero is between a 1 and a 3. So this zero is significant. You could treat it as if it was a 1 or a 5. It doesn't matter, because it's between two other significant numbers, count it as significant. Let's go through some of these numbers and count significant figures for practice. So in our first example, we have no zeros, so this is a straightforward example of counting 1, 2, 3, 4, 5, 6. The next example, the same is true, no zeros, so very straightforward. 1, 2, 3, 4, 5, 6 significant figures. Our next example, we are not going to count with including some of the rules we have for zeros. So in this example, our 2 zeros are between other significant figures and to the right of a decimal place, so we count them. 1, 2, 3, 4, 5, 6 again. In our next example, again, we have a 0 after another significant number and a 0 to the right of a decimal, and additionally, these zeros are between other significant figures, so they are included. 1, 2, 3, 4, 5, 6. In this example, we have zeros set up that are not after a significant figure to the right of a decimal place, so they are only here to hold the decimal place for a number, so we do not count these first 3. So we have 1, 2, 3, 4 significant numbers. In our next example, the same is true, so this doesn't matter whether there are 2 zeros or 4 zeros or 5 zeros at the beginning of a number. They aren't after a significant number, so they do not count. So this example again has 1, 2, 3, 4 significant figures. In this example, we have 2 zeros that are set to hold the decimal place for a number, and then another 2 zeros that are between two significant figures to the right of a decimal place. So these are included. And here we have 1, 2, 3, 4 again. In this example, we have a 0 between two other significant figures, so we count it. 1, 2, 3, 4, 5. In this example, currently we have 1 0 between two other significant figures, so this 0 will be counted. This 0, however, is to the right of a significant figure and there is no decimal place. So in this current demonstration, we have a total of 1, 2, 3, 4 significant figures. Again, we ignored the 0 because there is no decimal place. However, if we were to add a decimal, this 0 becomes significant, and now we have 1, 2, 3, 4, 5 significant figures. In our next example, we only have 2 because there is no decimal point after the zeros. We ignore them, so we have 1, 2. In our last example, these 2 zeros are to the right of a decimal after a significant figure, so they are included. 1, 2, 3, 4. And my motto is that if a 0 is added to the right of a decimal place, they are put there intentionally. There's a purpose behind adding those zeros there, and you shouldn't ignore them. Now let's try rounding these examples to numbers with 3 significant figures. So our first example, I'm going to round to 3 sig figs. We have 76.5. This 5 rounds up to this 4, and this becomes 76.5, and we get rid of the rest of the numbers. Our next example, because this is a 4, we leave this alone. We have 76.4. Our following example, we have nothing to affect this 0, so we just discard these last 3 digits, and we are left with 76.0. And you need to include 0.0 because we want to designate that this number is rounded to 3 sig figs. Following example, again, this 2 will not cause this 1 to round up, 70.1. In this example, our 7 rolls into our 9, which will round this up to 0.00330. Again, remember you have to include this 0 to total the number of sig figs to 3. Following example, we follow the same rules, and now we have 0.000373 because our 9 rounds into our 3. 3 significant figures. In this example, our 2 goes away, and we go from 0.03002 to simply 0.0300. Again, don't forget to include these zeros because we need to make sure there are 3 total significant figures. Our next example, these 3 and 2 go away, so now we have 1, 0, 3, and then 0, 0. Without a decimal place, these zeros are not significant, and we ignore them. Our next example, we're going to round our 5 into this 0, so we have 1, 3, 1. So 1 significant figure, 2, 3 significant figures. Without a decimal, this number only has 3 significant figures. So you can see that by changing the denoted and required number of sig figs displayed in a number, we can relatively drastically change a number's value. So here we are adding 50 to this total number. In this example, the previous before rounding has 2 significant figures. It remains the same. We just know that it has 3 significant figures. This can be corrected in our next step when we start to use scientific notation. So our last example, 1, 2, 3, 4, we simply remove the last 0, and now we have our number with 3 significant figures. So while looking at some of these numbers, we notice that some of them are kind of clunky, and then numbers such as this example down here, it is unclear whether this has 2 significant figures or 3. One way to correct for this is to use scientific notation. So scientific notation lets us move a decimal place and add a multiplication of a factor of 10 to designate what our number is and how many sig figs there are in it. So for our first example, we can move the decimal place 1 to the left and correct that by adding times 10 to the first power. So 7.65 tells us there are 3 sig figs in this number, and our value is really 76.5. In our next example, the same is true. We move the decimal point 1 to the left. We add times 10 to the 1 to designate that this number has 3 significant figures, and the true number is 76.4. Our next example, because we are retaining 3 significant figures, again, we move this decimal place, and now we have 7.60. Again, remember to include the 0 to denote that there are 3 significant figures in this example, and times 10 to the 1 to designate that the true number should be 76. The same is true for this example. Move the decimal place, add times 10 to the 1. And for our next example, we're actually going to shift the decimal place to the right. So we are going to go 1, 2, 3 places to the right. Our number becomes 3.30, 3 significant figures, times 10 to the negative third to denote the true number. Will have this decimal place 1, 2, 3 to the left, which will return it to this designation. The same is true for this example, except we are moving the decimal place more. So we are going 5 to the right, 1, 2, 3, 4, 5. So our number with scientific notation is represented as 3.73 times 10 to the negative fifth. The same is here with 2 decimal places moved, 1, 2. So we represent this again by times 10 to the negative 2. In this example, because we are only retaining 3 sig figs, and we're going to make this clear, we move our decimal place 1, 2, 3, 4 to the left, so times 10 to the fourth, 3 sig figs. This example, which I spoke about in the previous slide, now we can clarify that there are indeed 3 sig figs again. Move our decimal place, correct with our factor of 10, 1, 2, 3, 4. The same is true for this example. Now it is clear that there are 3 significant figures in this number, 1, 2, 3, and times 10 to the fourth to correct for where the decimal place should be. And our last example, this should be a 0. Don't be fooled by questions that incorrectly designate how many powers of 10 to move. So this should be 1.30 times 10 to the 0, because we are not moving decimal place at all.